Welcome to this explainer. Look, if you've ever stared at the Amazon Web Services database dashboard, you've probably felt that familiar wave of overwhelm. I mean, there are just so many options, right? Well, today we're going to conquer that paradox of choice. Think of this not as a boring lecture, but as a masterclass in building your ultimate cloud architect tool belt. By the end of our time together, you'll know exactly which data tool to pull out for absolutely any engineering challenge. Here is our roadmap for today. We'll be covering 1. The relational foundation. 2. Scaling fast with NoSQL. 3. Analytics and big data. 4. Purpose-built specialty databases. And 5. Choosing the right tool. All right, kicking things off with Section 1, the relational foundation. We've got to start with Amazon RDS, the Relational Database Service. Think of this as the absolute bedrock of traditional structured data storage that AWS has completely supercharged for the cloud era. The beauty here is that it's a fully managed service. AWS literally takes the heavy lifting out of provisioning, automated OS patching, continuous backups, and scaling. So you get to use the familiar SQL engines you already know and love, like PostgreSQL, MySQL, MariaDB, Oracle, Microsoft SQL Server, and IBM DB2, but without all those traditional infrastructure headaches. You're freed up to actually innovate your application instead of just maintaining servers. Now, to keep things running smoothly and provide continuous high availability, AWS uses a multi-AZ setup. Because let's face it, in the cloud, things can and will occasionally fail. With RDS Multi-AZ, AWS deploys your primary writer instance in one availability zone and a synchronous standby instance in a second zone. If an entire availability zone happens to go dark, the system seamlessly fails over to that standby instance. It ensures your database service remains continuous, which means no more waking up at 2 a.m. to fix a crashed database. We can actually take that high availability and build on it to massively boost performance. By adding multiple readable standbys, we are effectively separating your primary writer instance from your reader instances. And get this, you can have up to 15 read replicas. So by distributing read-heavy queries, like a bunch of users loading a product page all at once, across these replicas, your primary database only has to sweat about handling writes. This asynchronous replication absolutely supercharges your application's responsiveness and overall performance. But hey, if you need absolute peak efficiency, you're going to want Amazon Aurora. This is AWS's proprietary global-scale relational database, heavily optimized from the ground up for the cloud. It packs continuous backups, automated multi-region replication, and a really cool serverless compute option that dynamically scales in response to your actual usage. Plus, its storage automatically grows in 10 gigabyte increments all the way up to a massive 128 terabytes. The real kicker here is the massive performance leap. Aurora boasts a whopping 5x performance improvement over standard MySQL on RDS and more than 3x the performance of standard Postgres. Now, yes, it does cost about 20% more than standard RDS, but for highly scalable, demanding applications, that trade-off is almost always incredibly worth it. So that covers the structured stuff. But what if your data doesn't fit neatly into traditional rows and columns? That brings us to a really critical pivot. Modern applications, we're talking high-traffic shopping carts, real-time gaming leaderboards, or rapidly changing social feeds, they demand a completely different kind of flexibility that strict SQL tables just cannot provide. Which brings us to Section 2, scaling fast with NoSQL. Welcome to the wild west of adaptable schemas, unpredictable workloads, and massive horizontal scalability. These NoSQL databases break entirely free from strict tables. Instead, they use methods like simple key-value pairs, where a unique identifier points straight to a specific value, or flexible document stores. Because they are schemaless, you get rapid, frictionless evolution of your data models. Basically, if your app's data structure is constantly shifting, NoSQL is absolutely your best friend. Take JSON, for example, JavaScript object notation. You can see how these nested structures work. Fields like cars or address can just be added, removed, or tweaked over time without tripping over rigid constraints. Services like Amazon Document DB, which gives you MongoDB compatibility, natively store and index this JSON data. It's an incredibly powerful way to seamlessly handle complex data hierarchies that evolve right alongside your application. To put it in perspective, let's contrast the two directly. RDS and Aurora are your rock-solid structured foundations, perfect for predictable data. On the flip side, you have Amazon DynamoDB. This is your ultra-fast serverless NoSQL key-value tool. DynamoDB is engineered to handle really sporadic workloads and can effortlessly scale to crush millions of requests per second with single-digit millisecond latency. It even offers global tables for active-active replication across multiple AWS regions. Talk about scaling fast. But what happens down the road? Your application grows, you're hugely successful, and suddenly you aren't just storing active user data. You need to analyze literal mountains of historical data to figure out business trends. How do you extract insights from petabytes of data? That leads us right into Section 3, Analytics and Big Data. Now we're stepping away from daily app operations and diving deep into business intelligence. There is a vital distinction to make here between workload types. OLTP, or online transaction processing, handles your fast daily operations, like RDS logging a single new user signup. But OLAP, online analytical processing, is a completely different beast. It's built for complex queries on massive data sets. OLAP databases like Amazon Redshift actually use columnar storage rather than row-based storage. This makes them ridiculously efficient for spotting trends across giant data sets, where you might only care about looking at a few specific columns. And Redshift is an absolute powerhouse. By leveraging massively parallel query execution, Amazon Redshift delivers a staggering 10x performance advantage over other data warehouses when you are scaling up to petabytes of data. You just periodically load your data in, maybe once an hour, and then run deep, complex SQL queries to extract massive business insights. Of course, to manage scale like that, your tool belt has to include some highly specialized big data services. You've got Amazon EMR for running heavy open source frameworks like Hadoop and Spark. Then there's Amazon Athena, which I love. It's a serverless service that lets you query data sitting directly in Amazon S3 using standard SQL, and you literally just pay $5 per terabyte of data scanned. Pretty amazing. Combine that with AWS Glue for your serverless ETL, your data preparation, and Amazon QuickSight to build fast, interactive business dashboards using machine learning. Sometimes, though, your standard hammers, wrenches, and even your heavy-duty analytics tools just aren't going to cut it. What if you have highly specific, complex data relationships? For cutting-edge problems, you need something custom-built. Let's crack open Section 4, Purpose-Built Specialty Databases. This is where AWS really flexes its engineering depth, offering databases designed for extremely specific use cases. These are your precision instruments. Take Amazon Neptune. It's a fully managed graph database, tailor-made for mapping complex relationships with millisecond latency. Think of a social network where users have friends who like posts which have comments. Then we have Amazon TimeStream, a serverless time series database capable of chewing through trillions of daily events, making it a dream for IoT sensors. And for the finance folks, there's QLDB, the quantum ledger database. It securely records a completely transparent, immutable, and cryptographically verifiable history of transactions that can never, ever be altered. And finally, Section 5, Choosing the Right Tool. We have covered an immense catalog of services today, from traditional rows and columns to massive data warehouses and specialized graphs. So, what's the big takeaway? Successful cloud architecture is not about forcing one single database to do everything. It's all about matching your specific data challenge to the exact right category. If you have predictable, related data, stick to the structured SQL foundation of RDS or Aurora. Dealing with unpredictable traffic and needs schema flexibility, lean right into the NoSQL power of DynamoDB or DocumentDB. When it's time to crunch petabytes of business data, deploy Redshift and Athena. And never forget those specialty tools like Neptune or QLD for your highly specific niche requirements. By really understanding the distinct strengths of each of these services, you eliminate the guesswork. You ensure your applications run efficiently, securely, and cost-effectively. So, with your Cloud Architect toolbelt now fully organized and stocked, the only question left is, which AWS database will be the foundation of your next breakthrough application? Keep exploring, keep building, and I'll catch you in the next explainer.